In the free fall acceleration assignment, we're going to take a look at question number 1 to give you an idea of how to begin. Do question number 1 along with this video tutorial, and then do your best to answer questions 2, 3, and 4 yourself. A couple of things that you might note: free fall acceleration due to gravity is still constant acceleration, so we're using the same equations we practiced with for a week already. The difference, the only difference, there's really just two differences. One, you're going vertical instead of horizontal. So instead of delta x, we have delta y. The other is that we have the same constant acceleration due to the force of gravity. So anytime we have this, we're always going to be putting in a is negative 10. Now, one piece of advice: when you're trying to do these problems, if your object is going up, make sure delta y is positive. If your object is going down, make sure delta y is negative. Other than that, it works exactly the same way. Let's find out. Number 1, a stone tumbles into a mine shaft and strikes the bottom after falling for 4.2 seconds. How deep is the mine shaft? Okay, here we go. So something's falling, that means free fall acceleration due to gravity. So I'm going to make my list. Delta y equals, v equals, v naught equals, a equals, and t equals. Now the only piece of information there is 4.2 seconds. Well, there's actually more implicit information that's still here, and that's what we need to sort out. 1, tumbles is kind of a way of saying that it drops from rest. So v naught is 0. And specifically, if you see the word dropped, definitely v naught equals 0. We don't know the speed when it strikes, and we're looking for how deep. Well, deep would be how far. So in this problem, we're looking for the displacement. Now, since the stone is tumbling downward, we need to make sure that our answer ends up being negative, and you'll see what I mean when we're all said done. A negative answer means we went below where we started. A positive answer means we went above where we started. And the acceleration, we're going to plug in negative 10 meters per second squared, because that's our value for acceleration for all free fall acceleration problems. The equation we'll be using will be this first one here. You can see it matches, let me back that up. That is not correct. We're looking for delta y. We do not care about the final velocity. We also have this, this, and this. So the correct equation we want is actually equation number 2. So delta y equals v naught t plus 1/2 a t squared. Well, v naught is 0, so v naught t, the whole term, is 0, so go ahead and cancel it. And let's plug in. 1/2 times negative 10 times 4.2 seconds squared. Now, you can see there's a negative right there. We already expected our answer to be negative, right? So that's working out so far. 4.2, square it, times the negative 10, and take half of that, we get negative 88.2 meters. So how deep is the mine shaft? Now this is your displacement, but to answer it, it's not asking for a particular direction. So we can say it is 88.2 meters deep. We don't need the negative to answer the question. The negative implies negative displacement below where you started. So the rock started up here at initial position y naught equals 0 and dropped 88.2 meters. That would be the final position y, making the change in displacement negative 88.2 meters because you ended up less than 0. Okay, give question 2, 3, and 4 your best attempt and effort.